Hey everyone, welcome back to the channel and this playlist series. Over the next 10 videos, I will be covering some of the most important topics in the statistics that are essential for data analytics and data science. While we can't cover everything in the statistics because stats in itself is a huge topic, so we will be covering only the relevant topics which are very important for the data science and data analytics. So these videos are inspired by what I have learned from the channel called Campus X channel and other reliable sources. The main reason I'm creating this series and creating the YouTube videos because the more I explain to the more I explain a topic to the audience and more I research about it, the better clarity I gain myself. And of course, it also helps me to increase my visibility among the recruiters and document my learning journey. So, in today's video, we will be starting the first session of the statistics, which will be learning about what is statistics, what are the types of statistics, and what is the types of the data, qualitative, quantitative, descriptive measures, measure of central tendency, measure of dispersion, and all, range, variance. We will be learning each of this topic in the detail in coming time. So first of all, what is statistics? As the definition says that statistics is a science of collecting, analyzing, and interpreting and presenting the data to discover the patterns and make informed decisions about. So in simple words, statistics is a science of studying about the data, infer about the data, find the means find the characteristics of the data, which will help us to make the informed decisions about the data, which in turn will improve the business. So there are some points which by seeing the naked data we can't say, means what is the mean of the data we can't say. So with the help of stats itself we can say this is the central tendency, this is the variation in the data, and we can build the confidence interval, hypothesis testing, all types of the testing can be uh, done with the help of the stats. So it bridges a gap between the raw data and actionable insight, as rightly said. So let's move on to the next. What are the types of statistics? As I said, there are two types of stats. One is descriptive statistics, one is inferential. And in the descriptive statistics, we will be dealing with we will be dealing with the what has happened in the past, how has happened in the past, and what are the main insight from the data. We will be calculating the central tendencies, we will be calculating the measure of dispersions, and we will be plotting the graph, we will be analyzing the graph, analyzing the data. All this which relates to the study of the data which has been happened in the past is called as descriptive statistics. Like we will be averaging percentages, summarizing the data, organizing the data. It all comes under the umbrella of descriptive statistics. And in the inferential statistics, we will make the and one thing in the descriptive statistics we will be considering whole of the population for study, and in the inferential statistics we will be considering only the sample. So we will be making the prediction on the sample to make to which will infer about the population. So we will be inferring about the population based on selecting a suitable sample. So it deals with the probability and uncertainty. Like we will be doing hypothesis testing, we will be constructing the confidence interval, doing the regression analysis. So all that which involves in the inferencing, which involves making prediction or making inferences about the population based on the sample of data, that comes under the inferential statistics, which we will be learning in the next videos. So and the two main basic concepts which we need to have is population and sample. So population is every member of the group which we want to study, so it is called population. And like for example, the example is given all college students in the United States. So the problem with the population is The population is very too large, so to do a study on the population it's not possible. For example, finding the average income of each individual in the India, so the office bearers or the statisticians can't go to each of the individual and ask the income of the person. So to tackle this, what the statistician will do, they will take the subset of the population which is known as sample. The sample should be representative. The sample should be random and independent in the nature. So what do you mean by representative in the now in population? For if we take the example of this, finding the average income, so we should not we should not take the sample from only one state or one caste or one religion. So while constructing a sample we need to take a consideration of every state, every religion, every caste, every race, every gender. So taking a subset of these and then constructing a sample will allow us to give the reliable information about the population, and while making inferences about the population. So this is all about population in the sample. So sample a subset selected from the population must be representative and all allows the practical research, while studying entire population is impossible, as I said earlier. So let's move on to the types of the data. So there are two types of the data. One is qualitative data, one is quantitative data. So qualitative data which provides the descriptive, which will be in the descriptive in nature, which will be categorical in nature. So categorical in nature which cannot be measured numerically. So this type of data is known as qualitative, and further the qualitative data is divided into nominal data and ordinal data. In the nominal data refers to the data which doesn't have order in them order in them. Like if you have the data of rivers, Ganga, Yamuna, Brahma, Putra, like this, we don't have order in these rivers. These are independent of each of this. Like states are independent of each of this. So the such type of data are known as uh, nominal data. And ordinal data, as the name suggests, that there should be order in the data, like good, bad, good, excellent, best. So where there is order in the data, in the categorical data, we classify it as ordinal data. And and when we come to the other side, which is quantitative, numerical in the nature, so again there are two, which is discrete and which is continuous. So in the discrete data, we have the data in the whole numbers. So the data cannot be in the decimal numbers. So I can give an example where the data can should be in the whole number itself. So number of players in the football team, like 11. It can't be 11.5 or 10.5. Number of accident in the road, it can't be 2.3, 2.4. So either it may be two accident, either it may be three accident. So this is the discrete data. And while we come to the continuous data, mean these are countable. Often the whole numbers should be there. While we come to the continuous data, so it can take any value between the range. Like it can take the decimal value too. So for example, weight can be 62.7 kg, like this. So where we have decimal number, it it is continuous in nature. And where we have whole number which is countable, so that is discrete in nature. Moving on to the next measure of central tendency and mean. Let me rub this. So measure of central tendency, what does the measure of central tendency means is, it is a statistical measure from where we will get to know what is our central point in the data. What is our central point in the data? So mean. So mean is very commonly used measure. So which is nothing but average of all the values. Like here we will be summing up all the values, and then we will be dividing it by number of samples. We will be getting the mean. So the middle value is 35 for this data. But the problem with this mean approach is it is very extremely sensitive to the outliers. So if any one outlier is there, like exam score, one outlier like 500 is there, so the mean will be towards the outlier itself. Now I think it will be shifting from almost 70 or 80. It will go to the mean will be going, because the mean is very extremely sensitive to the outliers. So to tackle this only, we have another one measure of central tendency, that is median. So here median, what we are doing, median is the value where to the right of the median we have 50% of the data, where left of the median we have 50% of the data. So so in how we are going to calculate the median is, first of all, let's take an example. So we have some exam scores like out of 1000, like 300, where all the students are averages like 300, 400, 450, 500, 550. But we have some students like extremely like 1000 and 1000. So I have taken this as sorted itself. So to calculate the median, the data set which we are getting, we should first sort in the ascending or descending order. I have sorted it in the ascending order. We will be finding the median. Median is the middle value of the data. Like here, now we have 7, 1, 2, 3, 4, 5, 6, 7. So this 500 will be median. Now, if you have one more, in that case, I will be using the mean of middle two values. So the outliers will be at the extreme itself. If it is in the negative extreme, or if it in the positive extreme, so there will be no effect of the outlier. So it is very commonly used for measuring the central tendency. Here we can see that uh, this is normal distribution, where mean, mode, median are equal. This is normal distribution. But if you see here, there are some extreme values which is rightly skewed data. Because of these extreme values, the mean has been stretched towards the extreme value, and the median is here and the mode is here. The median is here means the 50% of the data is here, and the 50% of the data is accumulated here. So this is about the median. And the mode is majoritarily used in the categorical data. And mode is nothing but the frequency, the data with most frequency in a data set is called mode itself. So it is very frequently used in the categorical data set. Next comes to trimmed mean. This is very effective for the data set where we have extreme outliers on the both the sides. Like if you have a data set where we are having many data points only from 1 to 100, but we have some extreme values like minus 200, 200, 300. Here also we have extreme values like minus 2, minus 4 and all. What we can do in the trimmed mean is we will be trimming 15% of the data uh, from the starting and 15% of the data from ending, and we will be finding the mean of this. So we will get the measure of central tendency, and it will tackle the problem of outliers also. So here also removing 5% before calculating can help us to identify the central tendency if we have the outliers on the both the sides. Moving on to the measure of dispersion, which is range. So the need of range is, first of all, we should study what was the need of range. If we consider the two data set like this, 0, consider this as 5, this is minus 5, minus 20, 0, sorry, plus 20, minus 20. By looking at the data, we can see the difference. The difference is variability. The difference is variability. The spread. The spread is smaller, and here the spread is larger. But when we identify the mean will be 0 in both the cases, because when we try to add both the things, we will be getting 0 itself. So mean will be 0 in both the cases. But so mean is 0 means, are these two data sets same? No. So how to find out the true pattern of the data? We'll be having the measure of dispersion. So how will we find out the measure of dispersion is with the range function. Range tells us max minus min equal to range. Here the max is 5 minus min, which will be 10, and in this case we will be getting 40. So this is the spread. So this is the range. It is 40 in this case and 10 in this case. So the range helps us to find the spread of the data. So the problem with the range is, if we have any, so all of my data is concentrated here itself, but we have any one outlier, very extreme outlier like 200. So by calculating now, it will give a bad picture about, it will give a incorrect picture about our data. So it is extremely sensitive to the outliers, the range. So next measure of dispersion is variance. So variance is calculated as average of the square deviation from the mean. So this is each data point, this is the mean, and this is the number of samples. We will be calculating the difference between the each data point and the mean, and then we will be and squaring them, and then we will be adding of then we will be doing the summation of each data point like this, and dividing it by the n. So we will be getting the variance. So variance is nothing but the spread of data relative to the mean. Spread of the data from the mean. How much our data is spread from the mean? The greater the variance, the greater the spread. The smaller the variance, the smaller is the spread. One thing to notice is, variance is not measure of spread. It is not measure of spread, but it is proportional to the spread. Like if we have one data set and this is another data set, so this data set variance will be greater than this, because the spread, it is directly proportional to the spread of the data set. So to have a better clarity on the variance, let's see this. We have a data set 1 where the mean is 4 and the variance is 4.67. The mean is 4. Here the mean it is, and we don't have many extreme values like uh, we have only the difference 3 from the max, and 3 from the min. So the majority of the data has been concentrated towards the mean itself. So that's why we have got the variance of 4.67. Here also we can see, this is the first data set and this is the second data set. We can see the spread is very much large, because we have a mean and we have extreme values like 19 and 1. So here the difference is 9, here also the difference is 9. So there are extreme, the spread is much larger compared to this, and the variance is 48.7, which is quite reasonable, because we can see here the spread is very large. So this is the measure of dispersion in the variance. The problem with the variance is, you can see the square. So the output is not in terms of the input, it is in the square. It is in the square. So to tackle this, we have another one that measure, that is known as standard deviation, which is exactly equal to the unit of input. If you are finding the standard, if you are finding the variance of LPA, then we have the variance square uh, of some scalar value, but it's not in the case, but lpa square lpa square, but it's not in the case of standard deviation, because we will be having square root, so we will be getting in the same terms of lpa. And so the formula is pretty simple. We will be doing the square root of variance itself, and in the last we will be learning one measure of dispersion, and that is coefficient of variation, which is very important when we want to compare the data set with the different mean and standard deviation, because we can't compare the data set with the different mean and standard deviation, because uh, because it may be because of the units, one with the height and weight can't be compared, so we find the coefficient of variation with relative to the mean of the same data set, that will be in the proportion, in the percentage. So it will percentage. So standard deviation relative to the mean expressed as a percentage. Formula is standard deviation divided by the mean into 100 allows comparison between the different data sets. Yes. So here I have a data set where a number of guavas is 7 and the mean. So here we can see the mean is 4.29. 4.29 and number of oranges 7, and here also the mean is 4.29, but the difference in the variability differences in the variability. The coefficient of variation for this data set is 23 and 65. Then what does this mean? 65, what does it means? And 23, 65 means that 65% means that if we compare it with this, it is more spread, it is having more spread to its mean compared to its mean. If we see 4.29 is the mean, and we have the values like 9, we have the values like 1, which is very far away from the mean. But when we see of this first data set guavas 4.29, we don't have so much of extreme, only we have 6 to the positive extreme, and in the negative we have 3, which is only 1 or 2 units from the mean. So that's why the variation with respect to the mean is very low, and here we have very large variation. So this is all about the introductory video on the statistics. In the next video, we will dive into the percentile, followed by the key plots like box plot, five number summary. We will be learning about the scatter plots and all, correlation and covariance, and all that. Thanks for watching, and always keep learning. Thank you.